We're going to solve this system of linear equations using the method of elimination. Now, we just solved this problem previously by substitution, and you'll see that we'll still come up with the same solution even though we're using a different method. So the reason why this is called elimination is because what we're going to do is we're going to eliminate one of the variables. And you can pick and choose which variable you want to eliminate. You can either get rid of x or you can get rid of y. It doesn't really matter. You just pick one to eliminate. Now, if we take a look at these two equations as they're written, it probably would make sense for us to try to get rid of the x variable. And the reason for that is because the coefficient in front of x right now is positive 4. And negative 4, so that when we combine these two equations, positive 4x and negative 4x are going to cancel each other out, therefore eliminating the x variable. So again, it would probably make most sense for us to choose to get rid of x. But I'm actually going to choose to get rid of the y variable because I want to show you that you can still eliminate a variable even if the coefficients as they're written right now don't seem like they're going to eliminate each other right away. So if we take a look at the coefficient in front of the y's, we have 5 and negative 3. And if I were to combine these two equations as they're written, 5y minus 3y is going to give me 2y, which clearly has not eliminated. So what you want to do when you have a problem like this is you want to think about what number can you multiply each equation by so that the coefficient in front of that variable that you want to eliminate is the same. Okay, and then because the sign is already positive and negative, when we combine them, naturally it will cancel each other out. So when you are looking at the coefficient, think about a common multiple between the two numbers. So the first common multiple that comes to my mind between 5 and 3 is 15. So that means that I would multiply the first equation by 3 to get that 5 to become 15, okay? And then for the second equation, I would multiply that second equation by 5, so let's get 5 up here, to get that negative 3 to become negative 15. Okay, so we're allowed to multiply the entire equation by a number. However, I'm emphasizing that you must multiply everything by that number, everything on the left-hand side and everything on the right-hand side, so that you don't change the value of the equation, because we don't want to change the value of the equation, we just want to rewrite it so that we can eliminate one of the variables. Okay, so let's go ahead and distribute that 5 to every single term, okay, in the second equation. And then we also have to make sure that we distribute that 3 again to every single term in that first equation. So let me go ahead and rewrite that down here. So the first equation is going to be 12x plus 15y is equal to 42. And the second equation is going to be negative 20x minus 15y is equal to negative 50. Okay, great. Now we can go ahead and combine both equations and you'll see that the y eliminates. Okay, so positive 15y and negative 15y cancel each other out. Let's bring down negative 20x plus 12x, that gives us negative 8x. And 42 minus 50, that gives us negative 8. So we have negative 8x is equal to negative 8. Divide both sides by negative 8. Okay, so x is equal to 1. Now we have just found half of the solution to this system. And remember, the solution to a system is the x and y value that satisfies both equations. So x is 1, now we still have to find y. So to find y, what we're going to do is we're going to substitute the value for x into one of the two equations. Now it doesn't matter which equation you pick to put x back into. So I'm just going to pick the first equation, 4x plus 5y is equal to 14, and substitute that 1 in for x and solve for y. Again, it doesn't matter which equation you pick because the solution is going to be true for both equations, so it really doesn't matter which one you substitute it back into. Okay, let's go ahead and subtract 4 from both sides. 5y is equal to 10. Divide both sides by 5. And so y is equal to 2. So there's our solution. And notice it's the same solution as when we solved this system by substitution. Okay, next we're going to take a look at how to solve this system using the graphing method.